The right qPCR system can save you time, money, and headaches. But how do you pick the best one? Welcome to this step-by-step guide on how to choose the right qPCR system for your lab. Whether you're a scientist or a lab manager, this video will give you practical tips to make the best decision. Let's be honest, choosing a right system can feel overwhelming. There are so many models, features, and price points. It's hard to know where to start. But the choice really matters. Your system will be at the heart of your lab's research, diagnostics, or routine testing. So how do you make sure it's the right fit? We will look at 4 key areas: performance, precision, usability, and application-specific features. Let's dive in. When evaluating a qPCR system, think about performance and flexibility first. These directly affect how well the system fits your current and future needs. Start with throughput. Match it to your experiment size. For small projects or pilot studies, a low throughput system with 16 to 48 wells is often enough. For routine testing, the standard 96 well format is the most common and versatile. And if you're doing large-scale research, a 384 well system is the way to go. Next, multiplexing. If you need to detect multiple targets at once, look for systems with at least 4 optical channels. Some advanced platforms even offer 6 or more, enabling high-plex analysis. And don't forget dye compatibility. The most common ones are FAM, VIC, ROX, and Sci5. Chemistry flexibility is another big factor. A good system should support cybergreen assays for simple and cost-effective runs, TACMAN probes for higher specificity and multiplexing, and high-resolution melting for genotyping or mutation detection. Working with limited samples or expensive reagents. Check whether the system allows low reaction volumes, sometimes down to just 5 microliters. This can save money and improve sensitivity. And ideally, look for open platform compatibility, so you're not locked into one vendor's plastics or reagents. That flexibility saves money in the long run. Now, precision and performance. Temperature control is critical. Look for systems with less than half a degree Celsius variation across the plate. Better uniformity means more reproducible results. How your system reads fluorescence matters. LED light sources are efficient and durable. CMOS detectors offer fast, modern readouts, and CCD detectors are still a solid choice for high sensitivity. And don't overlook ramp rates. Faster heating and cooling cycles can cut run times dramatically. Some modern systems finish a full run in under 30 minutes without compromising quality. Usability is just as important. Good software should guide experiment setup, automate baseline and thresholding, and include built-in analysis tools. Cloud connectivity is another bonus, letting your team collaborate from anywhere. If bench space is tight, a compact footprint makes a big difference. And for high-throughput labs, automation features like robotic plate handling, barcode scanning, and LIMS integration are essential. Working in diagnostics? Make sure the system meets compliance standards for data integrity. Finally, think about your applications. For gene expression studies, look for fast cycling, high sensitivity, and easy normalization tools. For genotyping, you'll need high-resolution optics and strong multiplexing. And for pathogen detection, speed and contamination control are crucial. Closed-tube formats and rapid cycling can make all the difference. Before we wrap up, here are 7 quick tips. Demo the software. Make sure it fits your workflow. Talk to other users. Real feedback is gold. Request an on-site demo. Test drive before you buy. Plan for growth. Can you upgrade the instrument down the line? Think beyond the box. Look for automation, LIMS, and cloud support, VFO. Check consumables. Are you tied to brand-specific plastics or free to choose? Factor in service and support. Fast repairs, local techs, and training can minimize downtime. And of course, don't forget to budget for the full picture. Reagents, consumables, upgrades, and service contracts. The right qPCR system will grow with your research and support your lab's success for years to come. Before you go, if you found this helpful, hit subscribe, click like, and don't forget to grab your free guide, How to Choose the Right qPCR System for Your Lab. It includes a checklist, comparison criteria, and questions to ask vendors. The link is below.